Hey everyone, welcome back to our channel. Today we are going to explore something really fascinating, the Navier-Stokes Classifier. This is a powerful way to use equations that describe how fluid moves to help us predict things with machine learning. Whether it is predicting the weather, designing airplanes, or even analyzing financial market. This classifier can do it all. Before we get started, make sure to like this video, hit the subscribe button and share it with your friends who love learning about AI and machine learning. So let's dive right in. Navier-Stokes Classifier is a unique machine learning model that uses equation mean to describe fluid flow, like how air or water moves. What make this model special is that we can use this same equation to make prediction in different areas like weather forecasting, aerodynamics, and even finance. It combines real science, fluid dynamics with machine learning to solve tough problems and predict things that traditional model might struggle with. Navier-Stokes equations are set of mathematical equations that describe how fluid like air or water behave when they are moving. They tell things like conservation of mass. This means the amount of fluid stay the same. So if some fluid flows in system, it has either stay there or flow out somewhere else. Conservation of momentum. This is about how forces like pressure or gravity affect the way the fluid moves. These equations are used in engineering and science to predict how model fluids behave like different in different conditions, and now we are using them in machine learning to make better predictions. To really understand Navier-Stokes equation, we need to talk about few key ideas in fluid dynamics. Viscosity. This is how thick or sticky your fluid is. For example, honey is thicker than water, so it has higher viscosity. Pressure. This is how much force fluid is putting on something. You can think it like when you feel this pressure of water pushing against you when you are in swimming. Turbulence. Turbulence is when fluid moves in chaotic way, like when there are strong winds during storm. It is harder to predict but very important for making accurate models. To use Navier-Stokes equation in machine learning, we need to make some changes. Discretization. This is a fancy way of saying we break down the equation into smaller parts that computer can handle. Imagine turning a big puzzle into small pieces so it is easier to solve. Feature engineering. We pull out important details like how fast the fluid is moving and how much pressure it has. This detail, called features, helps the model to learn. Supervised learning. Once we have the feature, we use label data to train the classifiers. The model learns how to predict the features outcome based on the features. How to predict future outcome based on the features. This classifier has some awesome benefit. Physics based modeling. Since classifier is based on real science, it can understand complex relationship that other model can't easily handle. Interpretability. This classifier is easy to explain because it is grounded in real world physics. This means expert can understand and trust the model prediction. Generalization. Because the Navier-Stokes equation are universal, this classifier can be used in a lot of different problems for predicting weather to help in finance. Before we train this classifier, we need to prepare the data how. Variable extraction. We pull out key variables like pressure, velocity and viscosity from the equation. These are features that model will learn from. Data normalization. We make sure all data is on similar scale, which helps the model learn better. Dimensionality reduction. With so many features, we use techniques like PCA, principal component analysis, to simplify the data without losing important information. This helps the model work faster and more accurately. Navier-Stokes classifier often used in deep learning on deep neural network, which is great for handling complex pattern. Neural network. The model has multiple layers that allow it to learn complex relationship between the feature and the predicted outcome. Hyperparameter tuning. To make the model work well, we need to adjust certain settings like how many layers it has, how large each layer is. This is called hyperparameter. And by tweaking them, we can improve model accuracy. Regularization. We use techniques like dropout to prevent the model from overfitting, which means it does not just memorize the training data but can also handle new data well. Once the model is ready, we check how well it is working using metrics. Accuracy. This shows how many model predict were correct. If it has accuracy of 92%, that means it is right 92% of time. Precision and recall. Precision tells us how many of model positive prediction were correct, while recall show how well it is founded the actual positive cases. F1 score. This gives us a balance between precision and recall, which helps us see how well the model perform overall. To understand model prediction, we can use these tools. Feature importance. This show which feature like pressure or velocity had biggest impact on model's prediction. Sensitive analysis. This is tell how much model prediction change if we adjust one of the input variable. It helps us understand how different features affect the outcome. Visualization. We can use heat maps and other visualize to make the model prediction easier to understand and see patterns in the data. To wrap up things, the Navier-Stokes Classifier is an amazing tool that combines real-world science with machine learning. Whether it is predicting the weather, designing aeroplanes, or analyzing the stock market, this classifier is changing the game. As technology and data continue to improve, the possibility for the classifier are endless. Thank you so much for watching. If you enjoyed this video, don't forget to like, share and subscribe to the channel. I will see you in the next video. Stay curious and keep learning. And thanks for watching. Bye bye.